Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is find center of star graph. So the problem statement goes like this: you will be given an undirected star graph consisting of n nodes labeled from 1 to n, and in a star graph there is a center node, okay, and other n minus 1 vertices are connected to this center node, okay, and you are given a 2D integers array edges where each entry in this array represents the edge between two vertices. For example, if ith entry in this edges array represents u and v, so it indicates that there is a undirected edge between u and v, and you have to return the center of the star graph. Okay, so you have to return the center. For example, here the center is 2. Okay, so let's have a look at the constraints also before thinking of an approach. So according to the constraints, the number of nodes or the vertices will be of order 10 raised to power 5, and edge's length will be exactly of uh, n minus 1, which is one less than the edges, one less than the vertices, and edges, each edge will be of length 2 entry in the edges array, and all the vertices will be labeled from 1 to n, and it is mentioned that there are no self edges. It means that a vertex cannot be connected to itself, so u and v cannot be equal, and the given edges represent a valid star graph. Okay, so let's try to think how we can solve this. The very first approach that is coming to my mind to solve this particular problem is we can use a little extra space here, auxiliary space you can say. For example, let's say this is the graph given to you. Instead of numbers, I am using alphabets. I hope it's fine with you. So let's say something like this is given to us. Okay. So now we know that this is the center. So there you will also be given the edges array. Okay. So let's say the edges array is something like this. Now you can very well see that this C is occurring in every entry in the edges array. Okay, so let's say this is the edges array given to you. So if we count the frequency of every vertex, okay, all of these vertices, C will be having the highest frequency. So we can just use a frequency map. Okay, so the way key will be the vertex value. Okay, and frequency will be its frequency, vertex values frequency. Okay, in edges array. Okay, so you will be having something like this. C will be occurring once. C will be occurring 4 times actually, and A once, B also once, and D also once, and E also once. As you can see, C is occurring maximum number of times, so this is the center of the star. This is one approach. Here we have used some extra space. Okay, so time complexity wise, it was order of n. Okay, since we were just using a linear traversal here. And space complexity wise also, it was order of n, where n is the number of the edges. Okay, number of vertices actually. Okay, so because of use of this hash map, we were using some extra space, but we can definitely avoid it, and there is no need to do that much of work. First of all, you might be wanting to see the implementation of this approach, so let's take care of that. So this is the implementation. It's very concise and straightforward. So in the implementation, what we are doing here is, as we talked about, we will be needing a frequency map. So we are having one here, and then we are just, for each of the entries in the edges array, and for each of the vertices, we are just adding its frequency to the frequency map. And then after that, we are wanting to look for maximum frequency and what is the vertex having that frequency. Okay, initially both of the values are set to 0, because at least every vertex will have at least one frequency. So vertex frequency and its vertex value, and then you will be wanting to have the value of the vertex with maximum frequency. So maximum frequency vertex you will be returning. Okay, as we talked about the time complexity and space complexities, I hope it's clear. Now let's quickly move to the next approach. Approach 2. In approach 2, it is also based upon observation. What we can observe here is, let's take this example. Let's copy this image. I think the connections are not visible enough, so let's mark them. Okay, so let's say the edges array is also given to you. Okay, this is your edges array. Now let's pick any two edges from this array. Okay, let's say I picked this one, 1 and 2, and this one, 2 colon 3. Okay, now what you will be doing here is, there should be some commonality between these two edges, and that commonality will be your star, uh, center node. Okay, so you need to just find that center node. Okay, so let's say I go for the first node in the first pair, and I have a match of this node with these two. Okay, it should be matching with either of these two. If it is not matching with either of these two, then we will for sure say that the very next node in this particular pair will be the star of our graph, you can say, center of our star, you can say. Okay, so this is what we have to return. Okay, so first of all, you will check for the very first node by matching the first node with the two nodes in the second edge, and if it is matching, then you will return, and if it is not matching, then you will return the second node in the edge, first edge. Okay, so let's have a quick look at the implementation also. Things will be more clear in the implementation if you are not clear what's going on here. So let's take it to the board. This is the implementation. This is a single line implementation, although. So let's break it a little bit so that it can be visible enough. Yeah, I think this should be visible enough. So what we are doing here is, as we talked about, firstly we will be, 1 2 and 2 3. Let's take it to this board, this slide. 1 2 and then 2 3. So firstly we will be matching 1 with 2 and 3. If it is matching with either of these two, then we will be returning 1. But unfortunately this is not matching here with either of these two, so we will be returning 2. Okay, so 2 will for sure be the center of our star. So this is what we are doing here. If the first node is matching with the other two nodes in the second edge, then we will be returning the first node. Okay, otherwise we will be returning the second node in the first pair. Okay, so this is the whole logic. It's quite straightforward and do not require any traversal or anything. And about the complexities, both are constant here. The time complexity is also constant, and since we are not using any extra space, it is also constant. Okay, so it will give you the best of both worlds, space and time complexities both of them being constant. So I hope you are able to understand this approach also. And if you are still having any kind of doubts in either of these two approaches or any queries in general, then you may ask them in the comment section. I hope this solution walkthrough added some value to your journey of honing your DSS skills. I will see you in the next video. Till then, keep practicing and keep solving more problems. Thank you for watching.